There are three primary particles within an atom. They are also called subatomic particles. They are protons, neutrons, and electrons. There is a long history that led to their discovery, and to know that history, I advise you to read the textbook. But in this video, we are going to discuss the properties of these three subatomic primary particles. Two of them, protons and neutrons, are located within a region called the nucleus. The nucleus is a small, dense, positively charged region in the center of the atom. Now, it's very small compared to the entire size of the atom, and it's positively charged. What does it mean and why? It contains protons and neutrons. Neutrons are uncharged, while protons have a positive charge. There are three possibilities: positive charge, negative charge, or no charge. Protons carry a positive charge, neutrons carry no charge, and electrons carry a negative charge. So the protons and the neutrons are in the center, very dense small region called the nucleus, and it's positively charged because protons are there. Electrons, on the other hand, are located outside of the nucleus of the atom. They are very fast moving, and they occupy a lot of space compared to the size of the nucleus. Now, as I said previously, protons carry a positive charge and electrons carry a negative charge. Their charges are exactly opposite and equal, meaning that if we assign a value of +1 to one proton for its charge, the value of charge on an electron would be -1. On the other hand, to a neutron, we would not assign any charge. An atom as a whole is always neutral, meaning that it does not carry any excess positive or negative charge. How is that possible? That's possible because the number of protons and electrons in an atom, in a neutral atom, is always the same. If that was not the case, then we would not call it an atom. We have a special name for it, which we will investigate into later. Now, here is how we represent an element. Here X represents the symbol of that element. For example, if this was gold, the symbol for gold is Au. If it was carbon, it would be C, C for carbon. And we will look at various symbols when we study the periodic table. Here on the bottom left, as a subscript, we write the atomic number, and on the top left, as a superscript, we write the mass number. What is the atomic number and what is the mass number? Well, the atomic number is nothing else but the number of protons in the atom. So why is the atomic number the number of protons? That's what you should be asking. Isn't the number of protons equal to the number of electrons? Then why is an electron equally considered to be the atomic number? Here is the reason. You can always remove or add electrons to an atom and change it into something different chemically. However, when it comes to the number of protons, you cannot remove or add protons. Doing so converts one element to other. For example, the element right before gold is platinum. If you were to add one more proton in the nucleus of platinum, what you have just done is converted into gold, and we know that is not something that science tells us we can do. We have not heard of that. Many have tried to convert various substances into gold in the past, but modern science confirms that that is not possible. So the atomic number, or the number of protons, is like the social security number of an atom. It is what it is, and we cannot change it. Mass number is the sum of the number of protons and neutrons. And why is it called the mass number? The reason is all the mass of an atom comes from the mass of protons and neutrons. Electrons, on the other hand, move very fast outside the nucleus, and they practically have no mass. All the electrons in all the atoms in your body put together may weigh less than 1 milligram, and all the mass in your body comes from all the protons and neutrons in the atoms in your body. Hence, we call the sum of the number of protons and neutrons, the mass number. Mass number is given the abbreviation uppercase A, and the atomic number is given the abbreviation uppercase Z. Be very careful here. You want to place the mass number on the top and the atomic number on the bottom before you write the chemical symbol for that particular element. Can you figure out the number of neutrons in an atom if you see the chemical symbol of an element where there is a particular number here and a number here? Yes. Let's say that the atomic number was 7 and the mass number was 20. So 20 is the sum of the number of protons and neutrons. From that, if you can subtract the number of protons given to you here as 7, that would give you what's remaining, which is the number of neutrons. So 20 minus 7 is 13. That way you can find out the number of neutrons in an atom once you have provided the chemical symbol for that element. But what about the number of electrons? Since we know that atoms are neutral, whatever is the number of protons must equal the number of electrons. So if we had 7 protons, we would have 7 electrons as well. So be aware of that logic and be aware of how to do that basic math. Finally, here are the properties of protons and electrons and neutrons given to you here in the table. We already talked about the charge of an electron being -1, the charge of a proton being +1. One proton is +1. If you had 2 protons, that's +2, and so on. Neutron carry no charge, it's 0. Now look at the masses of all three given to us here in atomic mass units and in grams. In the atomic mass units, the masses are for the proton and the neutron are very close, 1.007 AMU for the proton and 1.009 AMU for the neutron. On the other hand, the mass of an electron relatively is very low. The proton is about 1840 times more massive than the electron, and similarly the neutron is also as massive, about 1870 times more massive than the electron. Here are the masses for all three of them given in grams. Now you don't have to memorize any of these masses for either any of the three subatomic particles in AMUs or grams. You should, however, be aware of the charges of each. So the main point that you get here is that while the proton and the electron are equal in magnitude but opposite in sign in terms of charge, their masses are way off in magnitude comparison. The electron is basically in terms of mass is like a feather compared to a proton, which would then be like a giant stone. For comparison, you can divide the mass of the proton by the mass of the electron in your scientific calculator, and you can see that it's clearly 1840 times more massive.